In this video, I will show you how to find complexities from code. I will go over some examples step by step so you can learn how to do this on your own. At the end of this section, I prepared tasks like this for you to practice. Let's begin. Let's find the time complexity of a linear search algorithm. One operation is initializing the value of I to 0. Then we check if I is less than n, and we do that n plus 1 times, because we also have to check if I is equal to n to exit the loop. Then we check if x is equal to our array element, and we do that n times. Then we increase I by 1, and we do that n times as well. And if we have found the element, break statement also goes off, but only once. It is important to remember that this is the worst case. We can also find the best case, but in this video I'll show you how to find the worst cases, as in algorithm analysis, this is the most common practice. Now that we have determined the number of operations based on the input size, we just have to add them up. So we have 1 plus n plus 1 plus n plus n and plus 1, which is equal to 3n plus 3. What complexity is this? Let's take a look at our graph. We can see that linear search algorithm follows linear complexity, as the name linear search algorithm suggests. It is just our f of n is equal to n, but scaled and moved up. In algorithm analysis, we don't care about the coefficient before n, and we don't care about free coefficients, so we just remove them. And we write the time complexity of this algorithm as O of n, as simple as that. Let's take a look at another example. We have a method that takes in an array and checks if the first element is equal to a number we want. Remember when I said that when finding a time complexity, we look at how number of operations grows depending on the input? Well, if you do, you should solve this in a second. The time complexity of this algorithm is constant, O of 1, because we only do one operation, no matter the input size. When number of operations doesn't grow as the input size grows, this is called a constant complexity. How about this example? Pause this video and try to do it yourself using the knowledge from previous examples. If you've done it, nice job. If not, here it is. We have a program that goes over each element of an n by n matrix. As always, we want to determine the number of steps we need to take depending on the input size. If we have a 3 by 3 matrix, how many operations do we have to do depending on the input size? Well, we have 3 times 3 elements, and we have to print out each element, so that is 9 times. What happens if our matrix is n by n? Again, we have to print n times n elements, so number of operations is n times n. If our input size is n and we have to do n times n operations, we can clearly see that that is a quadratic complexity, O of n squared.